Diamonds in the dark. Isn't that a trip, man? Wowie kazowie. This is a really nice one. You know how you know it's a diamond? It's 10 on the Mohs scale of hardness, for one thing. So if you try to scratch it with a known diamond, one of your little De Beers diamonds, you can't do it. I mean, you can gouge it, but you can't just make a scratch on it, right? Like if I try to scratch that with my brass monkeys here, I had brass monkeys, and I'll use one of their little feetsies or something, and it just escapes on it, right? You know that it's not gonna scratch, even if it was glass, probably, right? Glass is 5.5 on the Mohs scale of hardness. Brass is 4. Okay, so brass is not hard enough to scratch um, glass, even, right? I can scratch plastic or softer stones, but I can't scratch harder stones, gemstones. Even opal, which is pretty soft. Opal is 5.5, like glass. Okay? And when you measure the universe, you get a number. And, my battery ran out of juice here, but it's 60 millimeters. 60 millimeters. This is one of the smaller ones. It's a matching one. I have two 80 millimeter ones that are even more spectacular. Um, Among others, many others. And they come from my friends in Kowloon, China at Long and we call them paperweights because obviously you're not going to wear that on your little finger, and you're probably not going to wear it around your neck or on your head or anything like. It's too big. It's too big. So it's a paperweight. I think I paid $10, something like that, for this. They know what it is. You know how I know that? Because they cut it the right way. If they cut it this direction, the planes of cleavage parallel this angle here of the pavilion, and they open outwards, so that when the light hits it, the sparkles are around the periphery. Now watch. See what I mean? You can see through there. Like it's not like there's nothing there. I mean, other than the fact that my finger turned into 8 little parts of fingers, and among other, there's a whole bunch of little fingers. Anyway, now watch this. Turn it over, and I put my finger under there, and it fills up the whole thing. Fills up the whole thing. And that is a really good test for diamonds. So you can tell it's a diamond because it's got the sparkles around the periphery, and that's because of the way the planes of cleavage open out. It's 10 on the Mohs scale of hardness, and I don't happen to have any little diamonds handy. Maybe I do. Hang on. Yeah, sure. Here's a few. There's one. See, we've got we're looking at the top of this one, but this one was cut so that when you look at it this way, you get the sparkles around the outside. So, and that's why these things are so cool. You hang them in the window and they make rainbows. Very cool. So this is a good one for using for scratching other diamonds. But it doesn't look enough like what you guys are used to calling diamonds. So I'll try to find something maybe a little less. And oh, here's a nice one. This is one I wanted to find. I cut this one. It's a cabochon. Dirty. Anyway, and this one doesn't have much of a point on it. It was cut in India. But it's a diamond, and the guy tells me we don't cut anything except diamonds. He also actually cuts natural zircons in the same way, and he's very good at it. Anyway, watch. No scratches. These are diamond crystals. Joe, would you get something for me, please? All right, so there's another way to tell that it's a diamond, and that is diamonds fluoresce in all colors. Okay, and I've just got a green laser here, but if you shine a blue laser or a red laser on a clear diamond like this, they will glow in all wavelengths. Okay, and they don't, it's not just the light passing through, right? See, like you shine it on a piece of glass, and it just makes a little hole. It doesn't light the whole thing up. This is fluorescing, giving off electrons at the speed of light from the beta emissions of carbon-14, stimulated by laser light. And my blue diamond will also, and of course it's kind of dirty, and this one's kind of dirty, but, and they light up the whole darn thing, right? Not my red light. My red diamond ignores the green light, right? Because the green light is smaller than the planes of cleavage in my diamond. Okay, those planes of cleavage are opening outwards, remember? And the depth of formation determines the size of those planes of cleavage. The deeper they form, the closer together they are. And as light passes through, it bounces along those planes of cleavage, and it looks red in this case, because the planes of cleavage are exactly half the size of this particular shade of red. Okay? So, and I can shine a blue laser on it and it won't do anything, but I can shine my red laser on it and it lights up. Like these guys do, not around the periphery, but the whole darn thing, because of the beta emissions of carbon-14. Okay, so next, where'd that damn laser go? So there's that one. That one. And you can see it passing through. Blue diamonds are also kind of the same. You can see this is also responding to the green light. So is this one. Isn't that cool looking, huh? Other than the little hairs on it. So anyway. And the point is that diamonds aren't really rare or hard to find at all. Most people call them quartz. Okay? I think I paid $15 for a kilo of these from eBay. And they fluoresce when you hit them with a blue laser. They fluoresce in the ultraviolet, and we can use them to clean water. That ultraviolet light kills the bacteria in the water. And in particular, my sister did a science experiment when she was in high school and alive. She died right after she graduated from high school. She did so in a wheelchair from a kidney disease. Terrible thing. And this diamond, little pebbles that we find in creeks and stuff like that, these are from India. And they're tumbled in the water, as they tumble down with the water flowing, and they fluoresce in the ultraviolet, and it kills Staphylococcus aureus, the staph infection bug, and also those little amoebas that cause amoebic dysentery. I think I've got hashish in here or something. That's not hashish. Anyway, it's cheap. And I got it from Amazon. And so, somebody made money on that $15 a kilo, presumably. And I hope they did. I think it was a good deal. And I can use it to clean water. I put like just a handful in the bottom of a jug and hit it with a clear jug, right? A clear plastic jug of water. And I can hit it with the blue laser, and it will kill all of the bacteria that are in there. And if you add just a little tiny bit of hydrogen peroxide, it makes sure, and it stays that way. Ah, there's a nice little diamond. I knew there was another diamond in there, man. That's a nice one. So I got some big ones of these too. These are beautiful. This is kind of a pinky purple. And might even respond to green laser. Let's see. A little bit. A little bit. Okay, so because it's pink, not actually, which is the depth of formation is what makes the color. Okay, so pink is first, red, and green, yellow, green, and blue. And there are various shades of blue from here to over there. See that sphere? That's what that is. And you know what? I'm not like guessing. I checked. I checked with things that don't require a machine. The hardness, I checked the hardness. And you can do that just by trying to scratch it. Right now, here's a piece of opal from Ethiopia. Okay, now I want you to watch. This is pretty sharp. It's actually very sharp. And opal is supposedly 5.5 on the Mohs scale of hardness, like glass, but my diamond can't scratch it. I went round and round and round, and if that was 5.5, that 10 on the Mohs scale, the 10 on the Mohs scale of hardness is 5 orders of magnitude harder than the next nearest contender, which is ruby, 9 on the Mohs scale of hardness. And I've checked that too, and it's true. I have some real nice rubies and sapphires, big ones. And I checked about 10,000 times. And so I got this piece of opal, and I said, check this. And it's 10 on the Mohs scale of hardness. So there's some discrepancies in what we learn in the books and what is actually true. But if you don't know how to check, all you can do is regurgitate factoids. Science is all about measuring the universe we live in. It's not a diamond. Definitely not a diamond. It just, the light goes in, but the whole thing is not glowing. Bounces around a little bit on the cracks in there. But it's not glowing like this one does, right? Here is a piece of quartz from, I think, Montana. Okay, it has some carbon in it. It's silicon carbide. It's 10 on the Mohs scale of hardness. This is the same stuff as what they sell in jewelry stores as moissanite in a synthetic, or at least they say it's synthetic. But you know what? When you go into a jewelry store and you don't know any of this stuff, how can you know? And if you use a machine that's made by the people who run the monopoly for diamonds, you absolutely can't know, because you don't know how the damn machine checks. anything, and you don't know actually what it's checking. You're just pushing a button and regurgitating factoids. It doesn't mean you know anything about it. Science is not regurgitating factoids. It's measuring things with numbers. There's only 9 of them. Look, 1, 2, 3, 4, 5, 6, 7, 8, 9. 1. Again, 1 down there, and a 0. 1, 0, 2, 0, 3, 0, 4, 0. See how that works? There's only 9 numbers, y'all. And you know what? When you deal with metric, there's no fractions. Fractions are stupid. I have never ever used fractions, and in my entire life I've never had to add fractions. I've never had to multiply fractions or subtract fractions. I spent, I was put in a class. I didn't spend much time there, but in 9th grade, right, from Algebra 1, that's what they taught us, how to multiply fractions. So I ran away from home. I was gone 6 months, and they dragged my ass back just in time for the final exam. And I said, man, I don't know how to do that shit. So a fraction is one number over another, right? 1 over 2, and you're dividing 1 into 2 pieces. So if you divide 1 into 2 pieces, you get 0.5. Right? I've got a 1 here and a 0 down here. 1, 2, 3, 4, and there it is in the middle, 5. 0.5. Okay, so if I have 1/2, it equals 0.5. And I know that. I didn't have to guess about that. I knew that. And so what I did, instead of doing the stupid way the teacher tried to teach them, was I divided it out and just did the work, with the equation. And I got all the right answers. And they told me I cheated. That's when I left school. Fuck them. Because they're not teaching you how to do mathematics or how to think, or what they're teaching you is how to regurgitate factoids. That's not education. It's brainwashing.